Hello. Okay. So today we are on day three for Leetcode daily. So before we start this video, I want to mention that there is a possibility that I will not be regular with my Leetcode challenge, which basically simply means this Fire Emblem will be set to zero at some point because I'm very busy this year with a lot of other things. Anyways, let's start without any further delay. Okay, so we are supposed to go to problems and yeah, supposed to pick. So let's see. For the past 2 days, we didn't really get any chance to use the paint for showing an illustration. Maybe today we will be able to do something out of this. And seems like there is another string problem and there are 5,200 no lifers, doing lead code. So let's begin the timer. Given a string s and an integer k, return true if you can use all the characters in s to construct k polynomial strings or false otherwise. Okay, Annabelle. Nice input format, Annabelle. Um, if you guys don't know Annabelle, you should Google and actually watch the movie. It's a good horror movie. Okay. So yeah, let me check. Is this Annabelle actually Annabelle? Oh yeah, it's the actual Annabelle. Yeah. Okay. Actually, it's not that good. It's a little bit mid. I think it's just okay. Depends on which Annabelle you're watching. There's like bunch of Annabelle movies. Okay. So let me read it again. Given a string s and an integer k, return true if you can use all the characters in s to construct k polynomial strings or false otherwise. Okay. True, you can construct two palindrome strings using all characters in S. Some possible connections. Uh, Anna LBL, Bana plus LDA, Annalena plus B. Okay. This is false. It's impossible to construct three palindromes using all. Okay, the only possible solution is to put each character in a separate string. Okay. Hmm. Okay. And it's only 5 length. Okay. So to start off, our problem is basically I think when it says construct k palindrome string, it's just asking if we can at least construct k palindrome string. So I don't think the problem needs separate explanation. It's probably obvious from what's written in the problem statement. So I'll skip that. So let's start thinking about the problem. And this too, I don't think will require any actually illustrations. Like I can do all of it on Notepad itself. So yeah, so we kind of want to know if we can at least construct k palindromes. And I think k is up to 10 to the power 5. Okay. Hmm. Mm-hmm. Okay. Hmm. Hmm. Okay. So like first thing is we can like if we had to just check for one lettered palindrome, that just means individual characters. Like so here you have a and b e l, so that's like four palindromes that you can get quite. But no, it says you have to use all the characters. Wait wait I'm actually confused. Oh, okay. Okay. Now that I think about it, Oh, okay, okay, okay. The question actually needs some clarification. Let me actually type it down. So basically, so what is what is a valid palindrome string? So uh, let's say you have a string p, and you can decompose it into substrings. Substrings means okay, not okay, not substrings, just strings. You can decompose into strings s1, s2, let's say sn, such that uh, if you join s1 plus s2 plus sn, you get you get all the characters in p, or to simply say, you get an anagram. So what is an anagram? So an anagram is a word or phrase formed by so yeah, so basically we get a rearrangement of our original string. So we need to decompose our string p in several strings such that when we put them these strings together, we get an anagram. Furthermore, condition 2 is this is condition 1. Each each string si should be a palindrome. So these two conditions we need to fulfill, and whichever arrangement satisfies these conditions, that can be considered a valid palindrome string. Okay, so we actually need to make sure that all the strings that we are making, they are palindromes and they join together. When we have to come, oh, okay, okay. One more thing. Here, here n equal to k. So you need to make exactly k such palindrome strings. You need to make k such palindrome strings. Okay. So we need to make sure that we have some strings that when we combine, we get an anagram of the original string. Each string should be a palindrome, and we should use exactly k such strings. Okay. Now the problem is suddenly looking quite hard. So let's think again. Hmm. Hmm. Okay. So k is something, and we want s1, s2 up to sk from our string. Okay. Hmm. Is there some kind of necessary condition? Hmm. Okay, first and foremost, for palindromes, we don't really care about the actual arrangement of letters. For palindromes, all characters should have even parity. Frequency must be even. At most, one character can have what parity. So let's first think in this direction that in terms of parity, what we can get out of this problem. Okay. So let's say if we have an string with even parities and some odd parities. I think uh, we will be using the notepad today. So, so I'm trying to make it a point. Normally for these kind of drawings, I would use pen and paper, but I'm now trying to think on notepad because this is you will use not notepad, paint or something, some sort of drawing tool to actually think out loud in front of the interviewer. So I'm doing that as well. So I'll be doing some stuff in this text box, try to think out loud, and my text box just disappeared. I don't know why. So I'll try to think out loud what I'm trying to do. Okay, let's begin. So if we have, let's say, a uh, let's see, we have 5 A's, we have 4 B's, we have 2 C's. Okay, we have this kind of an arrangement. So when we are told uh, k is equal to something, we don't know. Uh, first time using this tool, so it's going to be a little tough. Like first time I'm trying to, not first time, but like first lead code day I'm trying to use this. Okay, 4 is sorry, we have 5 is, we have 4 is. Spacebar does not work. What is going on? Wait a second. What is going on? Why is it not working like a normal text box? Okay, now it is working. Not sure what was up there. Oh, I think the tab button does something. Like, uh, not sure. But hitting the tab button does something. Yeah, like the tab button definitely does something. I should avoid hitting that. Okay, so 5 A's, 4 B's, 2 C's. What we can do to like make it a palindrome? K is actually not, the K is quite small if we were to like think in terms of permutation. Actually, I think I'm misunderstanding the problem. Yeah, you're misunderstanding the problem a little bit. We don't actually need to. Oh, okay, I don't know why. Okay. The mistake I made. Let's let me put down what mistake I made. Mistake I made. I was counting uh, if I can. Okay. I was making some dumb mistake. It's kind of hard to clarify, but the mistake was I don't know, like I think I was not only trying to split the string into k palindromes, but I was also trying to check if I can get exactly k or more such palindromes. Like I was trying to add a condition on top of the problem. I was not just, checking if I can just get some k palindrome strings to uh, uh, I was not just doing what the problem was saying. I was also checking that if I can do it more than once, like if I can do the problem k times with different arrangements. So I was doing some complex version of the problem, but here we don't have to do anything like that. Here we simply have to check if there exists problem requirement. So like these kind of mistakes can be very dangerous in interviews. You think of a totally different problem and you keep thinking about that. So maybe talking out loud can help you avoid that. If your interviewer is nice and he catches on your mistakes, so he may be able to help you. But if you are not thinking out loud, just thinking in your head, then there is no way for the interviewer to know what you're doing. And if you have misunderstood the question, you could say that your interview is kind of over right there if you don't realize it real quick. So okay, the actual problem requirement is any k valid palindrome strings, like we any k valid palindrome strings from the string p. So we just need to check if we can find any such k valid palindrome strings by using the string p. If that's possible, then we return true, or else we return false. Okay, so then I feel that the problem becomes quite easy now, uh, kind of. So, mm, so I think k valid palindrome strings. Hmm. Actually, it is not still that easy. Yeah, it is not still. Wait, actually, yeah, actually it is. Actually, it is easy because the problem did not state if we can, like the problem allows us to repeat the palindromes. I don't think we have that kind of restriction that we cannot, like here it is b, so it does not like say we cannot use b again. So if we do that, repeat our palindromes, then the problem could be a little easy. Yes. So I think, yeah, the problem is on a little easier side. So what we can do is, we obviously, first requirement, we need at least k characters in the string. Also, this is kind of turning out to be not a DSA problem, but a little ad hoc kind of problem requirements, which is nice because like interviews are not always about DSA and implementation problems. Sometimes they are also about tricky thinking problems. There is sometimes a little bit of mixed match. So this kind of problem can come. So obviously we need at least k characters in the string, because if we don't have k characters in the string, then there is no way we can form k palindromes, right? Because we at the best we can use length one palindrome, that is the character itself. Like that is just one character. So we need k characters in the string. Otherwise, there's no way. Now, if we have at least k characters in our string, what can we do now? So one very simple thing we can do is that up to k minus one, we can just use one word, one word or a single character approach to k minus 1 length, we use k distinct, like k single characters, sorry, k minus 1 single characters. So now with the remaining letters, all we need to check is if with the remaining letters, all we need to check is if we can form a palindrome out of it. Just need to check with n. Let's say the string length is n minus k minus 1. Oh, sorry, k minus 1 characters. We can form a palindrome or not. Okay, so what should we do that we can cleverly approach this thing? Okay, so we know that some characters will have even parity and some will have odd parity, right? So what we can do is, suppose if there is a character that is odd, right? We have an odd character. So if we have an odd character, we can up to k minus 1, right? Hmm. If we have an odd character, I think if we have an odd character, we can always, we have to distribute the characters in k different partitions while making sure whatever partition it belongs to uh, is a palindrome, which means, but all our partitions are basically length 1 except for the last one. We are making it like that, that all our k minus 1 partitions have single letter words except for the last one. Okay, I have a simple idea. So, okay, let me think. So, if we have a character that whose frequency is just k minus 1 or less, we don't have to worry about those letters, right? Because those letters will not even arrive if if frequency of a character is less than equal to k minus 1, then we don't need to worry about it. See, does not appear in kth palindrome, kth potential palindrome. It's not guaranteed that it will be a palindrome, but let's just say potential palindrome. For characters whose frequency is greater than equal to k minus 1, so it's given that we definitely have to use it in the final string. Definitely have to use it in the final string. Hmm. So if we have to use it in the final string, there can be two cases. One is that the remaining letters for that character are odd, or otherwise they're even. If they're even, we are done. We don't have to worry. If they're odd, we still can transfer one character from the last string to the one of the earlier occurrences, because we used one length palindromes and two length palindromes are also valid. So like it almost makes me think that in most cases the solution should be true. What I'm saying is if frequency of character is greater than equal to k, then we can, for even case, for parity wise case, if even, do nothing, just if even just use it in kth string. If odd, transfer one letter to one of the earlier occurrences of the character, right? Because if we do this, it balances out. It, if for the second case, if the letter of parity is odd and we transfer one letter, then in the kth potential palindrome our letter becomes even parity, and for whatever previous occurrence we are appending it to, that becomes even. So that kind of balances out, right? Now the question is, in what case can this actually break? Because you would think that for most of the cases this should actually work, but it seems there could be cases where it can break. So where can this actually break? Oh, I see. Let me read through my conditions. So up to k minus 1 length, we use k minus 1 single characters. Just need to check if the remaining characters we can form a palindrome or not. If frequency of character is less than equal to k minus 1, don't need to worry about it since it does not appear in the final palindrome. If frequency of character is greater than equal to k, we can handle it accordingly. So now, what? Which case does this not work for? It says lead code. In this case, we cannot do anything no matter how much we try. As okay, so as you can see in lead code, almost uh, except for E, everything is odd. L, T, C, O, D, E, and yeah, like so here we actually notice that. Hmm. Okay. Okay. Let me spell it out for like why does even with our approach this lead code input fails. So let's say we have lead code. Let's say I'm using an arbitrary arrangement. What I'm doing is, let's say first we picked L, then we picked uh, let's say we picked T, and now we need to, because we have to use exactly three palindrome strings, so we have C, D, O, E, E. C, D, O, E, E. So as you can see, we are still left with these three letters C, D, and O with odd parity in the final string, and there is no previous occurrence of either of these strings, either of these characters C, D, O. So we cannot even transfer these letters to the previous occurrences. They simply don't exist. So since they don't exist, we cannot do anything with our way of approaching the construction. We cannot do anything. But does this mean our construction is like kind of universal? Like if our construction cannot provide a solution, does that mean that is it? That means it's definitely a false answer. So let's think a bit more. Okay, let's think a little bit more about this problem. I like this problem actually. Interviews don't ask these kind of problems. They ask annoying code, big solution problems, or code a lot of implementation logic problems. And with these kind of problems, I usually like to think silently because a lot of thinking is involved, but I'm speaking a lot here, so it's taking me a little bit more to process this problem. Okay, so let's think. Okay, so yeah, so when it fails, one case we can easily pick from the lead code test case if it's the odd transfer case and no earlier occurrence exists. So this condition is not the complete condition. This actually we took it out of this test case. This translates to something general, more general condition. We need to figure that out, I think. Okay, it's already 26 minutes. Okay. Um, okay, does not appear in the K potential palindrome. Fine. Let's just think about the uh, okay, so imparities. So um, let us hmm, so like uh, uh, let's see. So now finally, what we can say is let me think a little bit. Let me think a bit internally, then I'll translate it. So here we can, okay, I think uh, after thinking a little bit, the way I've been going around this problem, maybe we need to reconsider our approach a bit. So this approach felt like maybe it's good and it can kind of solve our problem, but I think this approach is a little more complex. Let's go with something more simple. So let's rename it as approach 2. Okay, so what we can do is, so our main bottleneck with palindromes is usually parity, right? K, K, K is okay. So I'm thinking of an approach where we really don't care. Okay. Wait, so okay, let's forget about K for a moment. Let's just throw it out of the picture and take the first case of our approach one. We said up to K. No, sorry, not even this. Let's talk about our requirements. We need at least K characters in the string. I said this right. So what we can do is we can extend this. Let's first not think about. So we definitely need this condition. That means we have more than, like, our string length is greater than equal to k. So let's make every character a palindrome. Now this works, but violates the k constraint. So what we can do is let's try to compress this. By compressing, I mean, so what I mean is, if if let's take the enable example. Okay, so let's make a n n a b e l l e. We have k equal to 2. Okay, so no, sorry, no. That's okay, not a problem, not a problem. Let me make a wait. Let me since I already did, let me just rename it as day 3. I pressed Control S, so it kind of, it's not a problem. Let's take another text box right beside it. Right. So here in Annabelle we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 characters. We need to compress it into two strings. So as I said, all of these are palindromes, but the only problem is that this is more than 2. We need to make it exactly 2. So what we can do, is first, uh, um, we can start compressing it. Hmm. So to compress, let's say about a. So at the very start, right? We can just use one letter and make it from A to AA. Make it from A to AA, right? Any subsequent additions? So yeah, so let's do this. Let's just kind of let's naively append the letters. Okay. So what happens if I take, let's say first, let's say A. We are taking A. So let's say I had two A's first. So now to reduce the length, what we can do is uh, bring them into one string. This reduces string count by 1 and still maintains the palindrome constraint. Let's see if we still had to reduce further. Okay, like we had to, like k was like our number of palindromes were still more, so we had no choice. We had to reduce it even more. So then we could do this. This reduces by 1 but breaks the palindrome constraint. No, wait. It does not even break the. Oh. Okay, nice, nice. Guys, we are actually pretty much done with the solution, I think. Yeah, actually, we are kind of done with the solution. Okay, so Yeah, so so see this is what happens. Sometimes you think that your solution is maybe, look, wait, I'll explain what happened. So basically what happened, before I explain what is exactly happening, so I was thinking that maybe when the parity becomes odd, the palindrome constraint breaks. But when you have a string with all the letters same, it does not matter what the parity is, it is always a palindrome. That's the only, like, there's only one kind of string where the parity is irrelevant for it to be a palindrome, and that is a string with the same character. So this still maintains everything. So we are getting a very nice construction out of this approach. Oh, fuck me, man. Sorry. No, no cuss words, but just came out. This came out instinctively. I didn't mean it. So yeah, so I actually press Control S. That's why the swear word. So okay, so what we got out of this is that we first we do this, break it all into individual characters. Then we start compressing it by appending it to the same character, and we keep you know we keep reducing the string count by one and still maintain the palindrome constraint. So we keep doing this because, yeah, so this does not, like, if we slowly bring all the a's, bring all the b's, bring all the c's together, we can slowly compress the length while not violating the palindrome constraint. But there is a possibility that even after we get all the letters together, like in this way, like this, our length of the string is still, like the number of palindromes is still more than our like for lead code. If we were to do this, L plus T, L, T, C, D, O, E, E. Even if we did this, we still had 6 characters, which is greater than 3, right? The K in the question is 3. It's still greater. So this may not be still enough. So we need to think a bit more what we can do here. Okay. We need to still think some more. Now what we can do is, uh, now we have to kind of, we are left with uh, not we are not left with a problem. We are now struggling that now how do we merge now? Okay, we brought all the characters together, we still maintain the polynomial constraint, but still our length is greater than k. So what can we still do? So now we need to kind of, we have to combine different characters together. There is no choice. Now when we have to combine different characters together, now when we have to combine different characters together, so every subsequent combination, like every time we append that character into the string, its parity will keep changing. Its parity will keep changing. So we can, okay, so we can now do this. Now we have all the individual letters. So, so ultimately, even after this, if it does not work, then we have no choice, but we have to merge the characters together. And if we have to merge the characters together, Then let me do a little bit internal thinking again. We have to merge the characters together. So now the parity thing does come into the picture. And in this case, mm, E, mm, gets into mm, mm, okay, okay. So we okay. So we need at least K characters. K characters. I've already clarified that as our first requirement. Other than that, we also did this. We first turned every character into a palindrome. We started compressing slowly, slowly. Right. So and we figured out that if we merge all of them into same characters, the palindrome constraint is not broken. Okay. Now there's one more thing we can do. We can still, kind of maintain this palindrome constraint thingy. But let's now, instead of reducing string count by one, let's reduce it by two. Uh, okay, so what I'm saying is we will still do this thing. We now what we will do is so now let's take this example. Uh, wait, let me take a different box. Okay, so let's take this example. 5 A's, 4 B's, 2 C's. So now how we'll merge? So let's say even after doing putting all the characters in the same place, our number of palindromes is still greater than k. So now instead of taking one character, we will take two characters. We will take two characters from any letter and merge it with any other letter, any other letter. For example, for example, we now do this AAA, BB, CC. So you can see we took both the characters of C, put them with B. What happened here is count went down by 2. Uh, wait, no, wait a second. Oh, hold on. Count went down by 2. That's true. That is true. Count does go down by 2. Count does not go down by 2. String count goes down by 1, but string count goes. The number of palindromes will still go down by one. No, 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 no. If the number of palindromes are still greater than k, hmm, well, even if we did take two characters from a letter, we would actually have to do more. It wouldn't suffice. So simply put it in words. Coming back to our previous case of AAA, BBBB, CC. If we want to reduce the palindrome count, we have to actually take the whole same letter string and merge it with someone else. So if we have to do this, right, there is way, no other way to avoid there's no other way to reduce this palindrome count. If we at this point we have no choice but to actually take the whole same character string and merge it into someone else if we want to reduce the palindrome count. Because if we leave some letters, if we leave, say I only take three letters of A and merge it with B, that will not reduce the palindrome count. That will not reduce the palindrome count, so it defeats our purpose. So now we have no choice but to take this whole string and append it with someone. So if we are doing this, if we are forced to do this, if we are forced to take the whole string and if you're forced to take the whole string and put it into someone else, then then I think it's quite obvious to say that we such a string cannot occur more than once. To clarify what I'm saying, that if after this arrangement, if after this arrangement we still, we are still over the k length, we are still over the k length palindrome. Then, as I said, now we have to merge same letter characters into another string. So in this case, if we had more than, like, if you say we had something, we had D D D D D, that is 5, right? Or E E E. So there's three such different characters with odd parities. If we had a case like this, if we had a case like this, oh, so before this happens, okay. So we can still do a comparison. Okay, let's take this case afterwards. This odd parity case. We can still do a compression. We can combine these. We can effectively combine BBB plus CC into one string into one string to still reduce palindrome count by one. So we can merge all characters with even parity to maintain constraint and still reduce palindrome count, right? We can merge all these same letters with even parity to maintain the palindrome constraint and still reduce palindrome count. So we can keep doing it for all the even letters, right? So now we are effectively left with a bunch of odd parity characters and one string with different characters, each having even parity. Did I erase something? No. Let me transfer it. Let's yeah. So after this, we have a bunch of odd parity strings, uh, characters, and one string with different characters, each having even parity. I think we're going a bit. I'm a little confused. Does this thing actually stop when I actually like not look at the screen, or does it keep going? Wait, let's wait 10 seconds because I think it's been way past 33 minutes. Like it has been way past 33 minutes, and I don't know why is the clock showing 33 minutes. Yeah, I think I'm pretty sure this timer stops when you don't look at the screen. Yeah, the timer definitely stops when you don't look at this tab. Oh my god, this is actually quite inaccurate timing. I'll actually have to use a stopwatch or something from next time to keep this going. Or I'll have to type it like this. No, it's fair to assume that uh, almost we are really like close to an hour since we started the problem. Nearly an hour since we started this problem. Anyways, we can't do anything about it now. Anyways, so back to the problem. So we have a bunch of odd parity characters and one string with different characters, each having even parity. So if after this, even after this, we are left with more than k palindromes. And we have the freedom of transferring one odd parity character string, uh, like merge it with this once with this special even parity string. That's like the one flexible we have got. So if after all these merges, like our problem is basically boiling down to this. Okay, so our problem is final approach is going to be this final approach. I think not many people will like a problem like this because there's good amount of you know ideas you have to think before you actually reach in the final solution. This is the most trivial check. You definitely need this. Next, you need to make sure that sorry, my mom entered the room. So back to the problem. Mm, so yeah, the final approach. We need at least k characters in the string. We need to mm, we need we count number of one second. Yeah, odd parity characters on number of odd parity characters and say that is x. if x minus 1 greater than k, then we return false. That's true. So let me explain this a little bit because this is a little abrupt. I went from talking a lot to just putting it into 3 lines. So give me a moment to explain what I did. Uh, hmm. So, so the first condition already checked, which is very obvious. Now we went through some approaches like this one, and this first approach seemed pretty good until we found a case where it fails. This 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 was looking like a very good approach, but then we saw the the test case which returns false, and we found that going through this line of logic will probably complicate our solution, and it's most probably going to be very wrong. It's going to be very hard to get this solution to pass. We decided to rethink our approach, and for that, what we did, we decided to split the whole string into as many palindromes as we could. Basically, one character palindrome. With this, we were able to achieve the all palindrome constraint, but the number of palindromes could have been greater than the number we need, that is k. So we did a bunch of stuff. We tried merging um, same characters together to slowly reduce the count. And then we were met with this problem that okay, we kept compressing them into the same characters, but it's not necessary that we will be able to reach this k. It still could be greater than k. So what now? Then after some thinking, we realized okay, all the even parity characters can be, you know, merged together because they don't violate the palindrome constraint and also help us to reduce the count by one. So after doing all of this, we were left with this construction, a bunch of odd parity characters and one string with different characters each having even parity. And I did not write it down. We had an additional, uh, you could say, just a moment, where is the, we had an additional free point. We can, we can use at most one odd parity string into a special even parity string, which is basically the merged even characters, basically this string. We can include at most one of these into the string to still maintain our palindrome constraint. If you don't know, that in palindrome, you are allowed to have at most one different character with odd parity and everyone else should have even parity. If you don't know this, you can Google this and confirm yourself. So yeah. So now I'll summarize how did this actually become our final approach. We need at least k characters. We're done with this. We are focusing on our very final construction that we got after doing all this mumbo jumbo. We finally got a bunch of characters with odd parity, and we got this one special evenish string which can allow us to use at most one odd parity string. So now I said let's count the number of odd parity characters and say that is x. So why did I do x minus 1? X minus 1 because having a string, that even special string, if we were to omit all the even characters, even if we like removed them, or like let's say they never existed in our input in the first case, they make no difference. 0 and 2 has the same parity. 0 and 4 has the same parity, if you understand what I'm trying to say. So that even parity characters effectively don't matter. Even parity characters effectively don't matter. So they don't matter, but we also said we had this flexibility of letting one odd parity string to exist. So which means minus one, like subtract one out of x, and we can allow k to be that or more than that. If k is equal to x minus 1 or greater, then we can achieve our objective, because we can no longer, reduce palindrome count cannot go below x minus 1. That's the conclusion. No matter how hard you try, if you try to merge one of these odd strings with the other one, you will be left with a string with characters, with two or more characters having odd parity, and that kind of string can never be a palindrome. No matter how you try to merge, it's inevitable, it will happen. So as a result, we have to just check this condition. If x minus 1 greater than k, then we return false, else true. Now let me actually code and submit and check if it's correct, because from all the explanation and everything we did, we're coming across like a 2 or 3 liner solution now, which is how most constructive problems work. This is basically, this is an ad hoc problem, and this is basically the worst category of ad hoc problem. This is constructive problem where you sit, make ton of doodles, take ton of cases, pray to God that maybe one of your approaches will lead you into the correct solution. I am very bad at constructive problems. I, if talk about competitive programming, I used to consider myself decent to okay in ad hoc, but constructive problems are like the higher level of ad hoc problems. If you are good at constructives in pure code forces language, if you are good at constructives, you are going to be very good at any logical thinking problem, with the exception of maybe greedy. Little bit. Greedy is also very similar in this case. These are all very mathematics oriented thinking problems. Now you would ask, where is the maths here? There was no maths. We didn't do any maths. But the thing is, this kind of problem requires that mathematical intuition to get the correct solution very fast. We also reached the solution, but we took so many trials and errors, and we basically took the duration of roughly 2 interviews of a lead code medium problem. So let me try and submit this and see if this is actually correct. So just give me a moment. Let me, like, I'm coming back in just a minute. Oh yeah, let's code our submission and check. Code is going to be very small. We just need to implement this. Int count odd equal to 0. Just check the number of characters with odd frequency. Let's just use a map because it really does not matter. There is no, there is, this is not really a traditional DSA style problem where they check your time, complexity, or memory. This is just a logical thinking problem. So I'm just taking a character map. I'll just count their frequencies, and no time complexity analysis, no memory analysis. It's simply you can see time complexity if you use an array, uh, normal array like 26 character array, then It's on plus the uh, constant O26, or you can just ignore it. It's just on 26 because you take a 26 length array to store the frequency. Memory is basically negligible. You don't do anything. You don't take any big data structures, nothing. So I'm just doing it and finishing it with the map because this is not the kind of problem we usually get in interviews. So let's get done with it. So iterate on each character. Honestly, oh my god, what happened? If it turns out to be wrong, I'll be very mad. One and two, honestly, I might just end the video because then it's going to extend to at least 2 hours, and I hope that does not happen. I hope that does not happen. Auto iterating, we're gonna take frequency ARR mem plus equal to 1. Okay, so now we will do. This is basically a way of writing syntax in C++. What it does is, in map, this is a map, there is a key and there is a value. So P and Q are basically, P is the key, Q is the value. This is a nice way of writing. This is a nice syntax you get in C++ 17 and above. I think it's there in C++ 14 as well. You easily get to name them like this and extract them from the map. It's so cold today. This is another way of checking if Q is even or odd. If this returns 1, bitwise AND. If it returns 1, this means you are checking the lowest bit of the number and checking if it's 0 or 1. So for odd numbers, the lowest bit is 1. For even numbers, the lowest bit is 0. So if it's odd, then we need to do count odd plus equal to 1. If count odd minus 1 mm, greater than k, return false. This should be it. Let's. There is nothing to actually check or no implementation details as such. Just simply checking this condition and count out minus 1 greater than k, then return false. Otherwise, just return true. Let's see. Okay, so it says uh, correct for all test cases. Let's submit it and check. If it comes out wrong, then we will have to take the test case and debug it on that. So let's try. Oh my god. Okay. Maybe I should end the stream. Never mind, I will not end the stream. Let's just go. Let's check what is it says A B C D. Okay, this is basically just uh, 26 letters, and I have returned true for some reason, but the expected is false. Hmm. What did I write here? Oh, 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 oh. Hmm. Uh, I think we made a little mistake. So it's not x minus 1. Right, 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 right. I don't know why did I make this mistake, but Uh, yeah, sure, we can compress an odd parity character string into a special even string, but I subtracted this one for this case. But why are we subtracting it? Like this also has to be a polynomial string. So and this is also a polynomial string. So our actual count of the polynomial strings is actually x. So if x is greater than k, then we return false as true. This should be the condition. We don't subtract the one because that is also our palindrome. Your code is safe to local. Okay, thank you so much, Leetcode. And I think this time we should be fine. Yeah, okay, we are done. Okay, so this whole discussion that spanned across two interviews of 1 hour, yeah, not even two interviews. Actually, it's even overboard for two interviews. So, like for one interview, if you take 40 minutes for just one problem, that's also a lot of time, realistically. So, we went like a little over two interviews duration to solve this problem. Good thing is that we didn't run into too many attempts of errors. That's good. But we had to do a lot of logic check and we had to come back and forth to so I'm pretty sure this problem has a lot of dislikes. Let's have a look at the dislike rate. So let's like go to classic. I think classic. It shows the dislike count. I'm pretty sure this problem has a lot of dislikes. Somehow surprisingly it does not. Only 133 out of 1491. I don't know how. I lead good people nowadays enjoying problems like these. But it's also true that not too many submissions have come forth so far. Is this a relatively new problem? Not sure. Did they like add this? Uh, somebody, no, yeah, you don't read hints for a problem. I mean, this problem is what? Just one condition check. If you read the hint, there's nothing left in this problem. Yeah, these guys who write this as easy are just retarded people because I will explain why they are retarded people. Let's read some comments. But all of a sudden, from previous folder is my loving. What they're cooking was this becoming easy. No, don't. Okay, well, I already explained. But the hint is the complete solution. Uh, this literally, what did they have three hints for? If the number of characters that have what counts is greater than k, then literally the hint two is done. The hint two, okay. Hint three basically hints you at how do you construct an answer if you know that hint you can apply hint two. Like if you know this false condition is not happening, how do you do hint three? Okay, good hints I think, but yeah, hint two just gives away the problem because people will not use their brains to actually solve it and think any further. They will just kind of code that thing, convince themselves with one two test cases and then just submit. So if this thing came in a contest, I'm pretty sure there would be a lot of wrong answers and not a lot of people that would like it. Okay, so uh, I'll discuss like 5 more minutes with respect to this problem. Some talk about my own history with problems like these and what you should do if you encounter a problem like this. So my personal advice: if you get a problem like this on Leetcode, just don't do it because 99.9% guarantee you will not get a problem like this in an interview because maybe I kind of suck, but effectively speaking, I feel 90% candidates will not get this. This is the hit or miss kind of problem, right? If you see the hint, the solution is trivial, right? If count odd is greater than k, if you just realize this somehow, you're done with the problem. Oh, and yeah, this case it doesn't even exist. It's just too obvious. It's so basic that anybody can figure this out. You get this solution, this line, you're done. Your solution is over. As you spend the whole interview trying to come up with all sorts of, concoctions, you come up with all sorts of constructions, you come up with all sorts of logics, and you see that it's wrong. And the interviewer also cannot verify this problem. Let me tell you why. For these problems, these guys made 109 test cases. They kind of the condition is easy to check, so the cases are very easy to make. But the interviewer cannot really test you on this problem very effectively, because the problem is, how should I say this? The interviewers, they might not themselves know the, okay, so sometimes interviews just randomly pick problems and just make random test cases. They may not know themselves what range of, but I guess, like, okay, not for this problem, for something similar that is more complex, that has more cases, let's say 4 or 5 cases or 3 4 cases. The interviewer themselves may not know all the cases that are required to completely solve the problem, and they will be testing you on a subset of the solution. So what the problem is, you will be solving in the interview the whole proper version. If you are a bit thought oriented, you may try to think a bit more, but your interviewer is maybe testing you on a subset of that problem, because he does not himself know that what all cases the problem can cover. So this is a bad problem if you ask in interview. The only kind of interview where you can get this problem is maybe some sort of brain teaser interview, or some maybe uh, some kind of company that really looks for thought provoking kind of challenges, that sort of company. I don't know. In software engineering, most software engineering companies will not ask you these kind of problems. Maybe in Google you can get this problem, but I don't think you will get it in others. Okay, software companies, in Google, or maybe in some quant firms. But in quant, they will ask even worse stuff than this. This is nothing in a quant firm. This is just baby shit in quant firm. So how do you tackle these kind of problems? So first and foremost, from my past knowledge as a competitive programmer, there is really no other way. One is obviously, as everyone will say, just practice more of these kind of problems. But the problem is, the issue with these problems is, if you know what kind of problem this is, it's already a hint. You knew, my gut feeling, and after playing around a bit, I knew this is a constructive problem. And I also fairly know that constructive problems have a very, very small solution. I already told, like, halfway through the video, that the solution of this problem is probably going to be very small. And I also know that the solution is something very exact, which takes a lot of trial and error for you to come up with. So it has a very specific nature. This kind of problem has a very specific nature. And if you are already told, you open the topics, well, it will not say anything here. See, here you will not find this tag, but if you open code forces, there's literally a tag which is called constructive algorithms. And the key idea is that whatever thinking you do, you have to do some doodling on pen and paper, and make some cases and construct some tests, and find this weird nature of the pattern that fits only some classes, some inputs, and that either it can be generalized into something like this, and you will get true or false, or something similar like 0 1 2, depending on what kind of output they want. So to practice these kind of problems, you obviously should practice constructive problems, but you should make sure that you are not aware that it's a constructive problem. So how can you do that? So if you are in code forces, you can, there is a way to combine tags with, like, you can do or combining. Let's say you want to practice implementation, you want to practice data structures, and you want to practice constructives, but you combine them with the or tags. So now when you search in the problem set, there is something called a problem set on code forces. You will get problems that may be implementation, that may be data structures, that may be constructive. So you don't know which tag the problem has if you keep your tags hidden. In that way, at least you know that maybe the problem could have this tag, but at the same time you're not sure. So that is one way of concealing this hint. the constructive hint. Another way is to practice mathematics and actual, thinking oriented mathematics. The stuff. So if you're a junior in high school, let's say in overseas US, or you are in India, if you have gone through something called joint entrance exam. So prior to that, people do Olympiads, maths Olympiads, mathematics Olympiads, these kind of Olympiads. They challenge you on these kind of problems, and there the emphasis on these mathematics problems is you must prove everything you claim. You must prove. You said five is a integer. Okay, this is very stupid and this is an example, but you must prove that 5 is an integer. You must have some evidence to back that up if you are going to use this fact in a solution. So there, because you have to prove everything, you have to make sure everything is definitely correct. You have the evidence to support it. You can just assume. You cannot assume. Yes, that's the correct word. You cannot assume anything in mathematics. So that skill of proofing, doing proofs, and grinding proofs really improves your ability to. It allows you to gain that kind of intuition to solve these kind of problems. And obviously, there's no better way than solving these kind of problems to get the actual hand holding. So the two-way fold approach is to practice a lot of thinking oriented mathematics, that is Olympiad level mathematics, any kind, uh, geometry, permutation, combination, uh, what else is there in Olympia, algebra, whatever, thought-provoking problems, and practice a lot of these kind of ad hoc. Ad hoc is basically a subset of this constructive for me. Ad hoc is usually easier. The observations are not something which come through patterns. You can read the problems, think of it, and you can see them. But in these problems, they are so ingrained in very weird patterns that it's very hard to take them out unless you do a lot of trial and error. It isn't easy for me because I have struggled with these kind of problems. So I will not extrapolate anymore into this. You can just Google code forces blocks. There are hundreds of people who have asked how to solve constructive problems. And you will get much more advice there than me because I struggled with these kind of problems and I still don't know how to solve them fast enough. I've practiced tons of these kind of problems and I still cannot. I fail solving them on some days if I'm giving an actual contest, or I manage to solve it, but I take a lot of time. Or some days I get very lucky and solve them in 9-10 minutes because this is just a one line solution. So, for these kind of problems, advice for Leetcode, don't do these kind of problems. If you want to do them just to learn, just to improve your problem solving skill, and you're not properly preparing for job switch, then do not. Then you can practice. And if you want to practice, then don't practice on Leetcode. Go to Code Force. And if you are just doing like for me, like job switch and preparing for software engineering interviews and stuff, just ignore these kind of problems altogether. You don't need these kind of problems. Just don't do them. So it was a part of my lead code challenge. I couldn't skip it, so I did it. So that's it for this video. It's a pretty lengthy video. I'm so sorry for that. My skill issue just peaked in this particular challenge. Let's hope we don't have to spend so much time in the next one. And thank you for watching, and bye bye.